Today we're going to be talking about sets and subsets. Your objective today is going to be to use visual representation to describe relationships between sets of rational numbers. I'll give you a minute to copy this down in your notes, and you can also pause the video as well. Okay, so first thing we want to do today is start off with a couple of vocabulary words, set and subsets. A set is a group of terms or items. A group of terms or items. A subset is a set contained within another set. A set contained within another set. Okay, so let me talk about the relationship between these really quick and give you an example. Let's say our set is going to be animals. Our subsets are going to be all the different types. So we have cats, dogs, and I'll keep it simple like that for a minute. So our set was animals. Our subsets are our cats and our dogs. We can either go further to say under the category of dogs, we have types such as German Shepherds, Chihuahuas, all different types. Those are also subsets. So we had the set was animals, the subsets were dogs and cats, and a subset of dogs would be German Shepherd and Chihuahua, just to give you a real life example. In this class, we are going to consider the set as our real number system. So all of the numbers that are in the world are in the real number system. That is our set, the real number system. The subsets are what are within that set or categorized underneath that set. So subsets of real numbers, subsets of real numbers would be our integers and our whole numbers and our rational numbers and our irrational numbers and so on. To make this even clearer, we are going to draw a graphic organizer in your notes. So if you draw a big circle, we are going to label this circle. This circle is our set. This is our real number system. And this is going to be our set if you want to label things. It's helpful if you were to go back and study to have these things labeled so that you know what each stands for. Within the real number system, we have categories or subsets. The two main subsets that fall right underneath the real number system include, you need to draw a big circle, rational numbers and irrational numbers. For the purpose of this class, we are only going to focus on rational numbers. A category down from rational numbers is going to be our integers. And within integers is going to be our whole numbers. So let's talk about this real quick and so we can explain this and understand how to read a circle map. Whole number. First, let's define what everything is. Whole numbers include any number that is whole. So we can have 4, we can have 40, or we can have 40,000. It really doesn't matter as long as it's a whole number. We can also have 500, 200, 660. Doesn't matter as long as it's a whole number. And it's also positive. When we move up a category into integers, I want you to know that integers contain all the whole numbers. If you can see, whole numbers is within integers, which means it's also considered an integer. Integers contain whole numbers. So the whole numbers we wrote down over here are 4, 40, and 40,000. Those are also integers. But the thing that changes in the integers category is that we now have whole numbers with negatives. So integers are any whole number, either positive or negative. So we can add in -4, -40. Integers are positive and negative whole numbers. Moving up to the next category, we have rational numbers. Rational numbers are going to be your everything else. So we have, not only is 4 and 40 still a rational number, and -4 and -40, but we now also have decimals. So 4.4. We also have fractions, so 1/3. You have a pie, you cut it into 3 pieces, you want to eat 1 piece, that's 1/3. We also have repeating decimals, 0.3 repeating. The reason why that's considered a rational number is because that, guys, can be converted into 1/3. It's also a fraction. So if we zoom back out and look at this whole graphic organizer as a whole, we can start to understand the relationship. Whole numbers are integers as well as rational numbers. Integers are rational numbers, and rational numbers are just rational numbers. So let me tell you something that's kind of fun that helps me when I'm trying to remember whole numbers, integers, and rational numbers. Whole numbers are integers, but not all integers are whole numbers. So every whole number is an integer because whole numbers are positive. So every whole number that's positive is also an integer. However, an integer is not always a whole number. Why? Because we have negative integers. If we follow this, we see we have negatives. We can't have negatives in the whole number section. So integers cannot always be whole numbers. If it's negative, it won't be a whole number. It'll just be an integer and a rational number. If it's positive, if we had positive 40 is all of them. It is a whole number. It is an integer. It is a rational number, and it is a part of the real number system, the set of the real number system. So I gave you some brief information today about the real number system and how we categorize it into sets and subsets. Remember, our set is the system. Our set is this real number system. The subsets are what falls underneath it into these categories: rational numbers, integers, whole numbers. All right, guys, that's it for us today. I hope you took good notes, and I'll be looking forward to go over it in class tomorrow. Have a good evening.